Vegetation monitoring is an incredibly powerful tool in relation to allowing the accurate monitoring of change over time in a given area. Reasons as to why the analysis of this data is important includes, but is not limited to, is that it allows the monitoring of change in biomass of above ground vegetation. This opens up further opportunities such as assessing different functional groups and plants' responses to climate change, productivity levels, determining which plants dominate areas, monitoring problematic invasive species, seeing what resources are available for animals, and also assessing the risk of wildfires. These all contribute to evaluating the ecological status of the site and ultimately helps gain understanding of how to best manage the said area for the future. Prior to commencing the first census, correct methods of establishing a plot must be undertaken in order to achieve the most accurate data. This includes deciding on the location of the core study area where at least 6 1-hectare vegetation plots will be set up. Guidelines include placement on a homogeneous soil type, lacking water bodies, as well as making sure the gradient of the ground is fairly consistent, so either the plot's on a slope or it's not. They should also be placed at least 100 metres away from trail or access points, but no further than 500 metres. The reasons for these guidelines and plot placement is so data is as consistent as possible while creating as little disruption as achievable. For example, water bodies would naturally affect the abundance of the vegetation in that said plot, and perhaps skew the data or misrepresent it. A reliable crew of 2 to 3 people must be formed who can uphold the integrity of the data by being as consistent as they possibly can be to minimise human error. Once training has been completed and equipment assembled, the plots can be marked out by beginning with the 2 100-metre long baselines. From there, the rest of the plot is formed following this structure as shown here. And equipment for making the plots is listed here as well. After GPS locations have been recorded, training has taken place and everything has been marked out, the census may now begin. Equipment needed is listed here. They must be measured within a 4 to 5 week period during the dry season yearly. The crew will split up and concentrate on previously established smaller subplots. The reason behind this is to make measurement easier and decrease the likelihood of missing anything. If the suggested route is taken, all of the point of measurements are done so that they are facing the tagger. This is to make recensus easier in terms of identifying where subplots begin and where they end. Once the tree has been established as physically in the plot and has a cleared trunk, the diameter is to be taken 1.3 metres above the ground. If it's larger than 10 centimetres, it's to be marked with the paint, tagged, recorded and given coordinates. Each person should be assigned different jobs in order to minimise the chance of error occurring, thus upholding the accuracy of the data further. The reason paint is used to mark the point of measurements and coordinates are given to them is so recensus data is consistent and stems are easy to locate. Naturally, you're going to encounter problems measuring some trees, which are listed here. A clear point of measurement will not be evident at first. This is when you refer to the protocol, as each problematic encounter has its own recommended way to overcome it. In a following visit, collections and identification of specimens can be undertaken to help gain understanding of the composition of plants making up the area, to perhaps help with further research and management. The process of recensus is much the same to the first. All the originally marked trees' measurement must be taken again, and additionally new stems making the criteria need to be measured, tagged, painted and sampled. Differences include if the point of measurement mark needs to be changed, for example if growing buttress roots have altered it, or if it needs repainting or retagging. Additionally, if the stems from the first census have been damaged, died or taken up some kind of stem irregularity, the outlined steps of what can be done are found in detail in the protocol. All of these problems should be noted when recording your data. Strengths of this method include not only taking the data on the circumferences of the stems, but also noting the species and thus representing density of particular plants, which can indicate levels of diversity and contribute to determining the ecological health of the said area. So it's a positive thing that with the data collected, various questions can help be answered. Additionally, the protocol is extremely in-depth. Something that may be considered negative is that the accuracy of the data can be affected in a few ways, through human error, weathering events, and also disruption to the site from either animals or humans. Overall though, I believe it's quite an effective method.